Hi, it's time for another math easy solution. We're going to discuss further into integrals and volumes by cylindrical shells, and now look at example 2 of the example series and solve this one, which states find the volume of the solid obtained by rotating about the y-axis the region y equals x and y equals x squared. I've solved the volume of this region in previous examples, but now I'll use cylindrical shells. Yeah, so now if we were to draw this region, well, we know how y equals x is just a straight line, so we draw it like that. That's y equals x, and now y equals x squared is going to look something like this. Is just a parabola, so it goes down initially, then goes, well, it's less than y equals x initially, but then it goes upwards like that, and this is the region right here. Yeah, and if we were to rotate this about the y-axis, it would look something like this. Well, we'll just draw a mirror image of this one across. Looks something like that. So there's this region, and now we rotate it around. It would look something like this. The top is really thin here, and then inside, yeah, basically we'll just look something like this shape. And at a random section right here, if we were to use actually now cylindrical shells, and let's say we wanted to pick a point here, we'll call this x right here, and now this point right here, we will rotate it around, and we'll actually draw a shell across it. Yeah, so actually this x is somewhere around. Let's move this around. This will be the x. Yeah, so that's the x. As you can see, there's a shell right here. The thickness is our delta x, or our dx right there. So yeah, just this is just infinitely small delta x, so that's that one. And now we're rotating it about this, so we'll have a shell, and will look something like this right here. And it's 3D, so it looks something like that. And again, now this height right here, that is just gonna be, because we know this is our x squared, or y equals x squared. So this height right here is gonna be the taller function minus the shorter one right here. So that's x minus x squared. Yeah, and that is our cylindrical shell. Yeah, so now if we were to basically write our volume integral, because we have this cylindrical shell, this equals to, well, now from 0, that's this point right here, and up to this point, that's, well, at this point where it intersects, we could just solve it right now. This is at where x squared equals to x, and basically at this point, this is equal to each other when x is equal to either 0 or plus 1, because if you put in 0, they're both the same. Put in 1 squared is still 1, so that's so this point is 1, and this is 0. So it goes from 0 to 1, and now we find the volume of the cylindrical shell, which is 2 pi x. So that's the circumference. So our 2 pi x right here. This value right here is x, and now the circumference is 2 pi x, just like I showed in my earlier video. And now the height of this is x minus x squared, and now times the thickness dx. Now this part right here, we could simplify this out, take the 2 pi or the constants out. Goes from 0 to 1, multiply this x inside, so x squared minus x cubed. Now this dx. And now we could solve this integral. So 2 pi, this is going to be integral of x squared is x cubed over 3 minus x4 over 4 from 0 to 1. So now this equals to, just plug in the 1, so we get 2 pi, now we get 1 over 3, just plug in this, minus 1 over 4. Now the 0, though, that just becomes 0, so we can ignore it. So this is 1 over 3 minus 1 over 4, and this one, if you use common denominator, times the top and bottom by 4, and this one by 3, so we get 4 minus 3. So 2 pi, 4 minus 3 over, this is 12. So this will cancel. This is just going to be 1, so we're left with pi over 6. And that is our final answer right here, and that's the volume of this region, and we use cylindrical shells, which is pretty easy to do. Anyways, that's all for today. If you learned from this video, and like always, you could download these exact notes in the link below, and thanks for watching, and stay tuned for another Math Easy solution.